Bark. Bark, bark, bark. Bark, 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 bark. Ah! Oh, God. I can't. Yeah, it's funny. You couldn't hear me. But I just said, I just updated OBS. Let's hope you can hear me. And then I even said I was late to my own party because I screwed up the beat drop on my join. It doesn't matter. It's fine. Let me check the other mic actually while I'm at it here. So let's quickly pivot over. Peace. And then we're gonna here, and I'm gonna click button, and then we're going to do one of those, and I see movement now. Haha, yes. Every single time OBS updates, you would think I would check. At least it didn't take me nearly as long to notice it this time, so that's kind of fun at least. It's fine. It all worked out according to plan. I mean, at the end of the day, I've only been live for 5 minutes. 3 of those was me just clicking buttons.
Bob, can I get a glass of water?
We'll grab that liquid, thank you. Appreciate that, kid. Hey, very good, very good. Hot tea this evening is all mighty fine. Okay. All right, I think I have everything that we need to do the trays tonight. I know we're not going to fully finalize because I don't know the batteries yet, but the trays, the circuitry for them, and we're going to join the different rails together. I should have everything I need to make that happen. So the goal for tonight is to make sure that when we say we're done, that at least one of the 2 trays I want to build is ready to accept the batteries. And then on the next go around of this project update, which is going to be a little while, because I'm going to have to source about $200-ish worth of batteries, which is going to take a little time, but that's okay. We'll want the trays to be ready to go. So I'm going to at least build this first one on camera so we figure it out, and then I don't know, I may do the other one off camera, I may do it on camera. I haven't made up my mind yet. We just need to just make sure that we at least got it all figured out first before I go to make a second one. So yes. So let me see who's here. I spy a Porsche and a gamer. Hello, hello. So here's the plan. Here's the plan for this evening anyway. I need to get down the soldering iron. That's the first thing I gotta do. And then we're gonna work on joining this stuff together. So I'm gonna switch scenes here. And we can do stuff and things. Want that one, and then I want to back up the camera because it's too close. It would probably help if I had the right camera selected. Yeah, here we go. All right, much better. There you go. All right, due to the nature of my setup, I can't hear music or the alerts, but I'm going to have my chat in front of me. I'm bringing you with me. I just won't be able to hear the alerts, but I should still be able to see them. I'm gonna go here, and then here. I'm gonna turn that down. I'm gonna toggle that, and then close that. All right, fantastic. Now I have chat with me. I'm gonna do a little show and tell before we start digging into it, so I could show you what we've got for this evening. Holy spinny, you little guy! Holy cow! I didn't realize you. Well, hold on. I am learning things. Hold up. How did you do that? There's a Gigafy. Try Gigafy. Huh. You have effectively blown my mind. I didn't know that was a thing. Wait, Bits, I don't... Am I dumb? Wait, are we sure it's not one of the... Oh, it's not bits. It's wait, no, it is bits. Oh god, my brain hurts. Okay, that's the thing I didn't. That's been turned on my channel probably for forever. I've never seen someone redeem it. Well, thank you for humoring me. I didn't know that was a thing we could do on here. That's pretty cool. I promise this is my channel. and at no point did I consider myself anything remotely close to a professional. I'm just good at laughing at myself. That's all I'm really good at here. Oh, good lord. Oh, cool. I don't know. We'll see what we want to call it. All right. Okay. The debate is real here. I just now remembered how close the parts are on the battery trays. That's okay. All right. So here's the running. Let me at least wander you through what's here. Because we're not using all of it tonight, but I at least want to show you where the direction is of what we're going to be doing. Because in addition to putting the battery itself together, we are going to have to put together the harness that's going to connect the actual head to the battery. So a couple things are going to happen. For starters, we need a pretty beefy connection between the different terminals within the battery itself. So what I have here is silicone coated 14 gauge wire. This is some pretty heavy stuff. And the smaller the number, the thicker the wire. So this is 14 gauge, which I'm going to see if I can get into frame here. There we go. That's 14 gauge. And then we also have with us some 16 gauge, which is smaller. And that's on this roll. Theory being is that we need this wire to be able to handle the power coming out of the batteries and going into the BMS, and then there's less amperage involved that connects the two segments together. So we don't need as thick of a wire because we're not going to pull a full 10 amps. Like this was rated for to be able to handle the full 10 amps that's possible to go to the BMS without the wire failing. And again, I also have it in both colors because we are working with a positive and negative. Once we get to the point that we are connecting the battery to the Protogen head, we have this thing called wire loom. So what this is it's a tube of nylon that will be able to run all the cables that go from the head to the battery pack into this. So that keeps everything nice and neat. And since it's nylon, it will be able to comfortably move inside of a material like a shirt or a jacket, and won't get hung up on it. If you've ever worked with cord before, you very well know that like a silicone like this, like if this gets wet, it's going to want to stick to you. That's the last thing you want, is for your connection to your battery pack to be getting stuck to you. So by making a nice smooth nylon tube for everything to ride in, then we're okay. And then we got some other stuff here. We have ourselves some, the internet refers to this as Kapton tape, but I had just recently learned that it's called polymyrite tape. It's a high temperature tape. And it's this really funky, like copper colored tape. The stuff comes in a variety of sizes. I got a couple different sizes over here that we're gonna be able to play with that we could use to insulate stuff. And then what were these things called? Insulator rings. So insulator rings are going to be the things that go on the batteries when we get them. These are just very crafty little stickers that are made out of the same material as the insulating sheet, which is this stuff. So this is a high temperature shielding paper. It could get really hot and it won't catch on fire. So it's used as an insulator. And the point of the little dots is to put on the top of the actual batteries once we go to assemble them. These are just my stand-in for the conversation. So those go in this area here to protect this white cap part of the battery. Nothing goes on the bottom because the bottom and then everything behind this blue tape is all the negative side of the battery. But we need to make sure that when it's in the pack that we don't rub through this area here, because if you do, that shorts the battery out and then the battery fails. So that puts us into a position where we can protect the ends. Now, we're not battery welding, but we are working with trays, and these trays do have moving components to them. So the battery will be able to wiggle around a little bit. We want to make sure that that small amount of movement is met with the level of protection to keep the batteries in order. And then in addition to that, we got two other pieces I'm going to show you. When working with any kind of electronics and a decent amount of amperage, just like you would expect in your own car, you want to make sure that you have a fuse on the circuit. So what we have here is fuse holders, and I kid you not, automotive fuses. I learned something recently in my research on this project that we're working on. Now, the wire that comes out of this holder is 16 gauge, which matches this roll. So when we have the connection that goes from the Protogen head through the wiring harness, through this wire, these match. So there's not a mismatch here. This isn't smaller and this isn't bigger. They're exactly the same size. Because we want to make sure that the harness does not have more power go through it than it's capable of supplying. Because what happens then is things melt. So in here is the tray where we'd be able to pop in our fuse, and then we have a bag of fuses. I realize I'm getting off topic from building the actual battery, but it's related, so I'm going to go off on my tangent anyway. With the grand scheme of things, I had discovered two other things in the research, and I missed it on the data sheet initially. This is our BMS. So this is the circuitry that's going to protect the battery when it's in use and when it's being charged. This is our regulator that takes the voltage out of the battery and then sets it to 5 volts. And then this is what gets fed into the project through the USB-C cables that we have that we're going to figure out how we're going to connect tonight. And we also have the wire that's going to get directly connected to that same little circuit right there. Well, I had discovered that this particular little board is maximum allowed to push 8 amps at 5 volts. The battery BMS is capable of handling 10 amp over the entirety of the pack. So that means we have a little bit of an energy mismatch. If this is capable of pushing 10 amps of power at 7.2 volts, and then this board is capable of dropping that to 5 volts at up to 8 amps, then that means that our harness is capable of pulling more power than what the board supports. So how do we protect that and prevent that from running into runaway? Well, that's where the fuse comes into play. We've already sized the project so that it doesn't pull more than, I want to say it's like 5.5 to 6 amps on the absolute highest side, which even in practice, I don't think it's going to come more than 4. Which means that if this is capable of only working up to 8, we're going to fuse the circuit with a 7.5 amp fuse, which means this will fail a 0.5 amp before we would come to the theoretical maximum of this voltage regulator, essentially. It's a step-down regulator because it brings 7.2 down to 5. This will protect it by popping. And inside of there is our really tiny filament, which is, see if I can get into focus here. If I hold it like this. Yeah, so in the middle of the fuse is the filament. that will burn out and protect the circuitry that's further down the line. Now, the BMS will never see more than 7.5 amps, and this will see no more than 7.5 amps because the circuit will pop. I'm here. Was fighting 4 chickens in a soap ferret. A soap ferret? Hi, Porsche. Welcome back. Here's something I found interesting about the whole kerfuffle with the fuses. For those of you who recognize this, this is a regular 12-volt automotive fuse. And that seems a little strange because I'm talking at 5 volts, but this fuse is rated up to 24. Well, here's something that I found that's unbelievably interesting. Fuses pop based on amperage, not by voltage. So if I could pull a whopping, say, 1 watt, and I get that 1 volt, and get that 1 volt all the way up to 7.5 amp, it's gonna pop this. It's the same thing as if I got the 12 volts all the way up to the 7.5 amps. It's going to pop. It's going to open. And that's because fuses are designed to fail on amperage, not voltage and amperage. I didn't realize that the two were independent of each other, which is fantastic because if I do end up, blowing a fuse, I could just take myself and my Protogen head to the nearest automotive place and pick up a pack of fuses. Which I'm not going to lie to you. Even if I don't blow a fuse, which I'm hoping I won't because I've rated everything appropriately, I really do want to walk into an automotive store and buy fuses for my head. The concept of that sounds amazing. Now, this is going to go on the harness side that goes up against the probe. So this and the fuses are not a part of tonight's conversation. All that's going to happen with tonight's conversation... Oh, Monster Hunter. Okay, that makes a lot of sense. I haven't played too much of Monster Hunter, so I wasn't really sure where we were going with that. A box of 50 is like $10. Yes, I know I can get fuses in bulk, but the reality of walking into a hardware store or into an automotive store and being like, I'd like your finest fuses to light my face back up. That just sounds like a fun time. All right, and then the other thing we're going to look at is the connection that's going to occur between the battery and the wiring that goes to the Protogen head. So I'm not going to lie to you, I kind of forgot what these are called. What are these called? These are XT60H-F power connectors. These you will have seen on things like remote control car batteries, the really fancy ones, because they're capable of handling very high power. And the way that they work is that it's like a banana plug style. So there's a male end and a female end, and then what happens there is that you join the two together, and then they're keyed so that they can only go in one way, so you can't accidentally mix up the positive and negative rails. So we're going to find ourselves in a position where we're going to technically be connecting 2 of these to the battery per battery. And here's why. For lack of a diagram, if we take a look at our BMS, we know that the battery is going to connect on the battery terminals, and the BMS is going to be in the middle of the back, right? So, all right, that's our first connection. To charge the battery, we need to apply power to the P minus and P positive on here. And then that is going to get connected to the regulating module. Now this P positive and negative is for in and out. It's for putting power back into the battery and for taking power out of the battery. Problem being is that if I put this regulator and connect it to the head, and that gets connected to a set of banana plugs, well, if this is my only connection to the battery, I now have no way to charge it because I can't take the power and go backwards through this regulator. I'm going to have to apply power to these 2 P pins, which means there's going to be 2 of these involved. One down here and then one up here in the circuit so that we can apply power directly to the BMS. Now the nice thing there is that if any reason that it comes up that we need more of the voltage of the battery pack, that's going to be our tap to get around the regulator. So there's the theory behind it. And then we also have, with these, I didn't show you them, but we have these nice little caps that pop on here to protect the back terminals. So that is the running theory. Oh, fantastic. They give you the polarity on here. I was looking for the positive and minus on here, and I'm like, I really hope it's marked on here somewhere. And it is. It's kind of hard to see on camera. I'm like, well, I'm going to have to connect it. I sure hope I don't do it wrong. Need more power. Exactly. So here's the angle for tonight. We're going to first work on joining the different sections of the tray to itself, and then we'll see what we can do to hopefully get the connectors in our two little boards here wired up. The only thing I don't have with me today is going to be the shrink wrap that's going to go over the tray. Once it's fully assembled and the batteries are installed, there's going to be a nice layer of shrink wrap to protect all of it, which will also help with insulating it to prevent shorts. That I do not have with me, but that's okay. That will be with me once we get to that step. It's in the mail. So, first things first. I'm going to set these aside for right now because we're not there yet. Main focus right now is our tray. Because the last I left off, we didn't connect any of these little connectors that we have on here. Now, by leaving it in such an orientation, we can quickly review that we have two banks of 6. So 6 in parallel this way, 6 in parallel this way, and then we have one series because we have the first tray connected to the second one. Well, actually, technically that's 2 series because it's two layers connected together. Or no, that's technically 1 series. That's 1 join. Yeah, there's 1 BMS on that. Yeah, so 2 parallel, 1 series. Yes, that's the connection. I promise I know what I'm doing. At least I think I do. So what we're going to do here is we're going to use our thicker wire to connect these little crimpy ends to join the 2 bars together. We're going to do that across the top here. And then on this side, we don't want these connected together or we'd short the whole pack together. So what we are going to do is we're going to see how difficult it is to try to just use 1 long piece of wire to go this way, because I would like to just crimp the wire on and then run it so that it just comes across the way here. I don't know if we'll be able to do that because the wire is going to kind of be in the way of the head that gets screwed onto the nut. We'll see what we can do there. Now, I had mentioned briefly on a previous stream that I got my hands on one of these wacky crimping tools that allow you to make the same type of connectors like these. And you crimp the wire and then pop on this little plastic guide. Well, turns out that particular tool, which is this one with the angry looking teeth, is actually the exact tool I need to terminate these little crimpy ends, because these little crimpy ends are exactly the same thing that this tool accepts. Now, thankfully, in the meantime, I learned how to use this tool, and I was initially using it backwards. So let me grab some wire cutters, and then I'll show you how we load it. Because initially, I put the connector in backwards, and I didn't realize how poor of a time that was going to lead to. So, all right, so I got the cutters, and now I need to grab the wire strippers, which I think I left up here. And these things are fantastic. I got this particular set of wire strippers off of a specialty shop that is for working with fantasy landscape. So like when you look at like a Lego village that has the nice little mock-up like house lighting, that's the type of wire you're working with. Something that's super, super, super thin. And amongst that, you need a very sharp and very precise set of strippers, which this very conveniently does do, because it gets to the insulation, it doesn't hurt the conductors, which I can promise you right now does most certainly come in handy, because it can go down to some pretty tight sizes. Alright, so first things first, what we're going to do, this is going to be a connection between a positive and a negative on the battery. So we're going to use just black wire here. Since it's two different polarities that are connecting together, the color doesn't really matter. It's just, honestly, if I had something other than black or red, I'd use it here just to indicate that it's a connection of a different kind. But we're just using what we have. So no worries there. The first things first, I'm going to take the crimp end off of both ends. Now, this isn't going to be an exact science, so we're going to have to kind of play the length here carefully. So what we have here is our end, and it crimps in two places. It crimps in the back, so it grabs the insulation, and then it grabs the conductor in the middle. And then the ring in the center is where you attach it to your thing. So the way that this tool works is that you load it upside down. And I was confused by that because I would have thought that you would have loaded it so that the fins kind of would have went in like that. Like I kind of thought it would have went in that way, but that's actually backwards. The way the tool works is that it pushes against the die, so you have to actually load it like this. Now, granted, you have to use the correct size, which I believe is the middle one. Or no, I lie. It's actually the largest one here on the bottom. And then when you squeeze the tool down, it causes the fins to push in. That's what we're going to do. And it's funny because when I first... this is like figuring out how to assemble the trays. This was one of those, like, I just did a quick Google and went, oh, that's how that works. And then it immediately made sense as to why I was having so much trouble when I was trying to use it before. Which kind of kills you, because when you don't know what you're doing, obviously you're going to try your best to figure it out. And sometimes there's no figuring. You just kind of have to you kind of just have to bite the bullet and ask or look it up. Okay, so first thing we got to do is we want to make sure that our wire, once I strip it, we'll make it so that the insulation can grab on the edges, and then the conductor can grab the wire. So we want to make it so that the black portion gets caught in these back fins, and then the actual wire gets caught in the middle. So I have to strip this enough to dab the thing. I know I'm doing it. I talk a lot. All right, so I got this, and then I got the strippers, and then I'm gonna nab this. Hopefully enough. Now this is also the flexible stuff, so that it's silicone and flexible because the battery is going to be flexible. All right, so we got that. And then that's what we should have. And then I'm going to feed this little monstrosity into the tool, and away we go. Alright, so let's see here. So got this. I try to guide this into here. This part's going to be a little hard to show, so I'm just going to kind of go for it. I say that as I struggle to get the goofy thing into the tool. No, almost. Yeah, man. There, got that there. Nope, don't go into the tool crooked. Come on now. Interesting, it crimped it, and I'm not entirely sure it worked correctly. Let me hit that again with the tool. There we go that way. Oh, I see what it did. Right. Okay. Well, that definitely didn't work because I gave it the tug pull and it wants to pull right out of the connector. So, if you're capable of pulling it straight out of the connector head, it was not a good join. So, that's exciting. Alright, well, I do have more than one of these. So I can try again. I don't really think I want to try to tin them first, because if I do that, I might find myself into a position where the wire will then be too big to fit into the gate. So I don't really want to do that. I know that if I don't catch the conductor, that won't work out too well either. Oh, I see the problem. So apparently not only is there an orientation, there's also a correct way that this has to fit into the tool. I just realized there's a separate incline by the teeth. So yeah, that was my fault. The tool did its job, I just loaded it backwards. There, hang on. I'ma get there. This is how we learn. We just screw everything up a little bit. Only a little bit. Alright, so we're gonna go in that way. There we go. I think I got it now. That looks promising. It's stuck. Don't be stuck. Wow, I actually got it jammed in the tool. Alright, well, good news, it worked. Bad news, it's stuck. So, in an effort, I want to be careful here because I need to get it unstuck and not break the tab. The tab is not exactly what one would consider sturdy. So, that's fun. I promised I used the right die. Let me grab my pocket knife. Actually, I'll be able to use the wire strippers to knock it loose. Actually, you know what? Do I have a tool here on the bench? Yes, I do. Time to grab out the Gerber. Huh. That's not a knife. This is a knife. Wow, I really can't even knock it loose. What the heck? Come on. Don't make me break the tab. There we go. Got it. Okay, good news. When you use the tool correctly, it functions as intended. Very exciting. Yeah, we just have to do that like a bunch more times. Now, I don't necessarily know if I'll be able to resurrect the other end here. Unfortunately, this particular kit did not come with extras. So, may have to get my hands on some extra ones. That's okay. It's fine. I'll get it figured out. Alright, so then for length, I'm going to do this super scientific thing where I just ballpark it. Let's see, so if we figured we're around there. It's going to be a comically short run, I know. Like, comically short, good lord. Yeah, the trouble is that they're on top of each other, almost to a fault. Because even if I do kind of loop it, as of course I drop that off the workbench, they're so damn close to each other. Maybe, you know what? I could do cross braces. I'll make the wire lengths a little longer. Because what I really need to do is just connect. At the end of the day, there is also the bus bars that connect all this together. I just want to make sure that there's enough power delivery across the sides so that we're not worried about, you know, melting. I don't really want to be melting. You know, maybe that's what we do. Because if I do cross braces, I go this way, this way, this way, this way, this way. We'll probably be okay. We do have all the copper that connects everything to everything else anyway. This just gives it somewhere to go. You know what? Let's do that. We're going to do that. That means then I'm going to grab this off of here. Try my best not to lose these in the meantime while I figure myself out here. Yeah, we'll figure we're around there somewhere. Okay. Have that. Get to keep rocking and rolling. Howdy, Pine. Welcome on in. just need a little more insulation up. I don't think I removed enough. All right, so then the thing I want to point out is that if you look in the teeth here, you can see that there's more surface area in the back than in the front. That's what I meant by I loaded it backwards. So then that also means that I have to be mindful of which way I load this into the tool. It's fine. Not that big of a deal. Every now and then I know I got it right. Like so. Ah, that one didn't get stuck. Alright, cool. So then there's the theory. We're gonna go this way. I know my connections are gonna be whatever they're gonna be. And so it goes. And again, I know everything's still kind of loose right now, so my connections are going to be a little loosey-goosey in the meantime. Because I'm going to have to adjust the tension for the batteries. And then all this has to get tightened down, of course. There we go. So we're just going to do that a couple more times. Oof. That was a really clean one. That went on really good. That's the idea. It's just so that it nice and tight, won't come off. So yeah, that's how the tool works, which is really convenient. I've got too many things on the bench. I also have to be mindful of what I'm cutting. I have so many just black wires on this bench. If I'm not careful, I'm going to cut something that's actually live. I'd rather not do that, but you know, this is where spatial awareness comes in handy. Try not to damage anything too terribly expensive. You know how it goes. Missed the context. What's a wig? Oh, yeah. Shorting out something. Exactly. I mean, it would be an expensive wake-up call. That's not something I'm particularly fond of. But you know, maybe what it is. It needs more power. I hope not. These trays don't have power, at least not yet. I'll be coming soon. How you doing, Hunter? Welcome on in. I removed the right thing. Yes, I did. There we go. All right, so we got that. And that's going to be our next connection. It's the dangling wire. That's the one I want to remove the insulation from. No, I haven't yet, Porsche. Today I have, as you'll have noticed, my starting time was much later than usual. I haven't, done any peeking in there yet today. Eat. That is easily my new favorite tool. That crunch it makes is so satisfying. No, thrift store's open. Well, that means you can do a little thrifting another day then. Excellent, nice and tidy. Oh, an Xbox One for $60, that's pretty good. But the fact that everything everywhere just seems to be becoming more and more hilariously expensive, it's nice to see a deal every once in a while. Alright, so we got that, and then we'll do probably one more. Actually, no, we'll do two more there on this side. Do one there, yeah. Oh, okay. Yeah, it's been a hot minute since I've had myself open a console before. I remember the days of working on the Xbox 360 and it being exceptionally angry and wanting to be, you know, baked like a batch of cookies because soldering joints decide to come loose, which is always a fun time. Some tools for opening electronics. Well, to be fair, if you're thinking about going down that rabbit hole, I can tell you something right now. The best thing you can pick up is a nice set of precision screwdrivers, something with a bunch of different sizes, because you will by far end in the lap of some very, very strange looking driver heads in some very odd places. I don't know what it is with manufacturers and deciding to choose every shape under the sun but the one that you would normally carry on a daily basis. I think they do it just for fun sometimes. I'm kind of convinced. Yeah, kind of missed the insulation on that one, but it's on there pretty good, so should be all right. Oh, prying tools, yeah, like the guitar pick style ones and the what do you call them? The like the flathead opening tools. Yeah, it's been a hot minute since I've had those kind of tools. Remember my first time attempting to fix something with integrated circuitry in it, and I promptly destroyed it. Sticks, yeah, there you go. Well, it was one of those things that I was not smart enough to know about ribbon cables at the time. So I promptly shredded any remnants of what would have been the ribbon assembly on the inside. This is what we call a learning moment. And unfortunately for the individual who I was attempting to help, a very expensive one. Alright, we got that. That looks pretty good. Nice. That was real solid. Lucky enough to find a PS1. Oh, cool. The PS1 Slim or the chunky version. $8 for it. Nice. The fat one. Gotcha. Alright, so we got that, and then we got one more to do between here and here, and then I can save that extra one on the end. I'm just going to take it off because I'm not going to use it. But I think this will give us more than enough capacity for the battery to be able to transfer its amperage between the bars and the additional wires to secure everything. Oh. I would highly recommend a very nice light coating of Clorox to help with that particular problem. Because that's a situation that's not exactly the most pleasant to be in. Loosen this one up a little bit so it's off. There we go. Oh, it's nice. Did it come with both controllers? Or did it just come with one? PlayStation 1 was a very interesting console. That's for certain. Nice. Good solid connection. That's there. Figure in that on that way. Somewhere right around there. Oh, okay. One controller and original memory. Roger, roger. All right, good, good. Okay, and I'm going to take off this loose one because we're not going to use it. Oh, okay, cool. Thank you, Porsche. I'll check that out after stream. Okay, good. Put that off because we're not going to need it. Pop that back on there. All right, so for the time being, that's going to be the sides of the tray. We have a total of 1, 2, 3, 4, 5 connections on top of the bus bars. And I think that's going to be comfortable enough so that our energy can transfer without much issue. Math is for blockers and a little Antron for tokens. Oh, that's fun. Now we get to talk about this side. Knowing how very much in the way the wire will be, I think we're just going to omit these connectors between everything here. We're going to use them though to get the wires that are going to have to connect between the BMS and the regulator, between these two pieces. So I'm just gonna work these off, and then we'll add back what we need. Because for the time being, I can't think. Because if I crimp anything on here, like I would love it to just like crimp like the wire on like that. But the reality is, we have the bus bars. I just want to make sure that there was a good enough connection between the two battery banks so that we didn't run into any trouble there. So we'll just ride with that for now. Xbox 360 games on Xbox One. Oh, okay. The oh yeah, that's right. Because Xbox One still had the CD-ROM tray. That's right. It was the Xbox Series S and X are the ones that. Actually, no. The more expensive one did have the disc tray. The cheaper one didn't, though, which is frustrating. To say the least. The more I look at all this little hardware that I'm using to put the thing together, the more I'm kind of wishing I just went with the battery welder method. You never understood parallel and series. Well, the best way I could describe the difference is that if you have a single pail of water sitting next to an additional pail of water, so they're side by side, and you were to dump both of them at the same time, you're going to get a you're going to get all the water. Nah, that's not really a good way to describe that. Parallel, you could think of like just taking one battery and making it a larger battery. So if you've got one battery that holds, say, 1,000 milliamps of power, and you pair it with another one that also holds 1,000 milliamps of power, well, then that gives you 2,000 milliamps. 1, 2, and 3 zeros. 2,000. When you've got them in parallel like that, the voltage doesn't change because it's just like having one big battery, but the capacity doubles. When batteries are in series, the capacity, this is where things get confusing. The capacity technically doesn't change, but the voltage doubles. So if you've got bad time for an ad, that's okay. I'll be happy to repeat myself when Porsche's back. When you've got batteries that are in series, then your voltage doubles and your capacity technically stays the same. Now, here's the thing that's a little confusing about that. The sticker capacity stays the same, right? So if we go back to that same idea of 1,000 milliamp battery in series, so on top of another one that is in series, they're on top of each other, it's still a 1,000 milliamp of capacity, but the voltage is twice as much. So two 3.7 volt batteries in series makes 7.4, which ironically is what we're doing right now. We're putting the trays together to take two sets of 18650 cells and putting them in parallel to increase our capacity, but then also going in series to increase voltage. Good, you're back. Repeat that for you. When the batteries are in series, the voltage doubles, the capacity technically stays the same. So if you have those same two batteries that are in series, and they're both, say, 1,000 milliamp each, well, then the battery is 1,000 milliamps at twice the voltage. So instead of 3.7, you get 7.4. But here's the funny thing, that extra capacity doesn't just go away, because the effectiveness of a battery is how many watts it puts out. If you do the math, the watt output of two batteries in parallel and two batteries in series is the same. It's the same amount of potential energy that comes out of the pack, which is handy because by doing our pack both ways, we're not stepping up voltage, we're stepping it down, which from what I could tell is supposedly more effective in its own right, which is kind of interesting. Yeah, it's that part I recently learned, and it was kind of one of those moments, because I wanted to make sure that we would get the most effective use out of our battery pack, but in that essence it doesn't really matter all that much, which I'm like, okay, that's kind of weird, but so it goes. Okay, so now that we've got that figured out, we're then going to need to have a connection that goes from anywhere on this side to the BM pad, which is this corner pad of the battery regulator, the battery management system, the BMS. Those are the letters I'm looking for in my brain. And then we need to connect our minus and positive of our BMS to the battery pack. So what we're going to do is we're going to get ourselves some lengths of wire, the thick stuff we have right here, and then we're going to measure to get them about the length we want, and then we're going to solder them onto here, and that's going to make our battery connections to the tray. Now the nice thing is that since we have a bunch extra of these little ends, this is how we're going to attach it to the battery, which will make it nice because we still have to insert the cells that we don't have yet. And for those of you who did not get the opportunity to see the tray, the positive end is the non-moving side, and the negative end is going to be the springy side. These can actually move, so the batteries have the ability to have a little bit of local motion in them, which will keep them firmly seated in the tray. And then we have these little clear covers that go over the top to make sure everything stays properly seated. So then the next thing we have to figure out is where on earth are we going to stick it? So I figure that once installed, if I can line some stuff up here, we're going to have a bunch of these little clear caps over here. Now we do have the insulating tape, as I had mentioned earlier. So I think what we're going to do is we're going to make it so that this will just sit on top of here. And then once the batteries are installed, we'll use the high temperature tape to just tape this here. And then the entire battery casing will get shrink wrapped. So this is going to have a layer of tape and then a layer of shrink wrap over top of it to keep it firmly in place so it doesn't jiggle around on the battery. We do have this nice flexible 14 gauge wire. So as the pack moves around with me and we move about, that should keep the components solid to the battery. So I figure then, let's plan to put the BMS, I guess we'll plan to put it actually near the middle. And we'll figure that we'll do that probably for both of them. So if we do that, actually here, let me actually just pop these on so that we can kind of play around with that thought, just to kind of get an idea of what we're playing with. Oh, that's the other thing too. Once the bus bars are tightened down, that's going to also put a little bit of pressure on this cap so that it stays put. So we're going to temporarily just toss these back on right now. Make sure that we cut everything to the appropriate length. And then the whole pack will be a little less shaky once we put the once we tighten everything down, because these won't be all as loosey goosey as they are right now. What are you laughing about? Oh, won't be loosey goosey. Got it. Well, it's true. It won't be loosey goosey. I don't really have a silly flavor for it being firm and seated. But I feel like the words kind of do its own justice. All right, I'm only gonna put the covers on the one side right now because I'm gonna plan for us to just put it somewhere on here. So we needed to make our minus and positive connection and then our connection over here. So let's think about how we want to position this stuff, because that's going to dictate how long we cut these wires. So we know that we have our positive and negative of the battery, right? And I want haunted, only a little haunted. Now again, we have insulating tape, we have the insulating paper, so I want to do a couple things here. I want to put the these things on opposite ends. So we'll have the ability to charge the battery and its contact point somewhere over here, and then we'll take the end that's going to connect to the Proot. This is the wrong end of the connector, but you get my point. Over here on the other end of the battery, right? So if we're planning on putting these somewhere near the edges, you have 25,000 points and I have almost no redeems. I'm sorry. I really need to sit down and put more of them together. I'm bad at that. As you can see, Project assumes the position of taking most of my time as we sit here and watch me lose my mind. But that's a part of the gig. Okay, so we're going to probably have these a little longer so that they're just kind of sticking out in the breeze outside of the shrink wrap. But the theory is that I want there to be a connection. I guess technically if this is down here, we would have that down there, right? So we have that there, positive, negative. We run that over. We hit both of those. I guess technically speaking, to just make life really easy, if I'm looking at this properly, if I go positive to positive, that puts the connector like that, and just have it shoot straight out of the battery pack right by where the BMS is, which actually wouldn't be such a bad idea. Maybe we'll do that, because we need to attach the battery itself to these points. Or actually, no, the battery goes over here. The power has to attach between this plug, the two lines on the regulator, and then the USB-C, and the plug for this has to be on this side. So we should hopefully be able to do this. If I orient it that way, our negative and positive ends are going to be over here. So, I think that's actually the way we'll orient it, because then this connection just has to make it to this bus bar on this side, which will leave this kind of along a little bit of the shorter side. But more importantly, that'll also secure this, because it'll be tacked on both sides here. And then this will just kind of stick out in the breeze. All right, let's do that part first. So let's let's work on the battery side first. So we're going to assume that we're going to put it over here. And it's okay if there's a little bit of length on these, because it's just going to kind of be suspended on top of the pack anyway. Now I'm looking at the negative post right here, because we can see the spring section right there, which means our negative is only going from here to here, and the positive is going to go over top to the other side, which again, it's both fairly short runs. So if we figure that we're somewhere about halfway, we'll go from there, and we leave a little bit of room on that. We figure we're around there, and we can just punch this down on any of these. Doesn't have to be a complete direct thing, because then this also gives a little bit of flexibility to the battery as well. So yeah, let's figure probably about that long. Okay, so the next thing we know is we're going to crimp one end and then solder the other. So we'll do the crimp end first, since I have those tools out already. Alright, so there we go. We have our little end here ready to go. Give ourselves another one of these dudes. Now this is going to be our direct connection between the battery pack and the rest of the project. So we have to make sure that this is a very, very good looking connection. Because if this one's not a good connection, then the rest of the project is going to have what we've referred to as a bad time. Both for me and for everything else that's downstream. We'll make sure we're seated, and we're going to send it. Alright. That looks pretty good. Now, a couple things are going to happen here. Before I get out the soldering tools, we do need to work with a little bit of shrink wrap. Because we have a nice kit of multiple sizes, and we're going to initialize it. Now the run is not particularly long, but that's okay. Since I haven't soldered it to the other component yet, we can pick on a size here and send it home. There you go. That's fantastic. Now, it doesn't need to be that long, so I'm actually going to save myself a little bit of heat shrink and just cut this in half, because I do need to make a couple of these. So we just kind of aim for the middle here. There we go. And then I'll hit that with the lighter, and we'll be good to go. So, yes, there's a hot air station. No, it's not plugged in right now. All right, cool. So, a fun little piece of lore. I am a big fan of collecting specialty lighters, and they do the job incredibly well. This is a dual flamed one. And it, it's easily one of my favorites. Now, naturally, I can't use the electric one because I would definitely burn some stuff. So, definitely don't want to do that. Alright, so... Yee! Actually, I don't know how well that came across on camera, so I'm gonna just actually do it again. So, open. We get blue flame, release, and then it moves to the nose of the dragon. Fantastic time. The jeweler shorts. Yeah, no, that's totally fair. Okay, so before I bust out the soldering iron, we're going to also prep the positive, and that we get to do in our nice red. Alright, so then we're going to figure probably about, middle of the battery tray. And then we have to be kind of cautious about this because we really don't want to short anything out. Our positive is over here on this side, right? So if we figure, I'm debating if I want to go across. I don't really want to go this way because if these are kind of a little sharp. If that runs through, it's going to blow the battery up. So if we go this way and then contact, and then just securely, because we're going to plan on doing a little bit of tape. I think that's what we'll do. We'll go around the corner. You're telling the green isn't positive? What? You're confusing the toaster. When did I talk about red wire? Red wire. Let's try that again. Green wire. Telling me? I am confused. I am confused. Well, if I said something, I might have confused both of us at this point. Oh, okay. Noted. I have the spatial awareness of a potted plant. So, yeah. Not not the smartest bulb in the box. Yes, I said that wrong on purpose. You don't have to be sorry, it's fine. Ain't no big deal. I am fantastic at SpongeBob references, but anything outside of that, yeah, your guess is gonna be as good as mine. Exactly. Not the brightest, not the brightest knife in the shed. Yes. Yes, that's fantastic. That is perfect. It crushed the silicone in the connector. That ain't going nowhere. Good. Now, we're going to put our little piece of heat shrink on there. Just slide it down to the other end. That one looks good. Yeah, tap this one a little bit more on this other side. Alright, solid. So now we have our connections that are going to go to the BMS. And then we have one more we're going to prep. And that's going to be the BMS line. So that is going to be one more of black. And that's only going from the distance of here to over here. So this is going to be another little short one. So we'll plan, probably tack this right in the middle. I'm not going to really plan going too terribly far with this. But we'll leave a smidge of excess on it so it has the ability to move around. Nothing too terribly crazy, but, you know, do what we can. So we got that. Now I'm going to be completely honest. I have no idea how much electricity goes through the BMS side, or the BM line, the one that's the balancer line. I don't necessarily know if we need one this hefty, but I already have this out and it fits the connector. So I'm not going to question it. We're just going for it. Because a slightly thicker wire on something that could potentially use a thinner wire is not going to bother anything. Because the reality is it just won't use the extra capacity of the line. Amperage is draw based anyway, so if it's not going to draw a whole bunch of stuff, then we're not really too worried about it. I need another piece of heat shrink. Another piece of heat shrink. Now, you may have noticed that I did not use heat shrink on the connections between each other. I purposely didn't do that on purpose because this whole area of the battery is going to be covered with the protective insulative paper, which is that roll of green paper I showed you earlier. And I'm not too concerned. I think that's going to be more than enough insulation, and it's all the same. It's all the same. What do you call it? Words aren't working for me right now. It's all the same polarity through that area of the battery, so we'll be all right. All right, solid. All right, cool. So now we've got 3 wires that are pre-prepped. And now I'm going to make myself a little bit of room, grab out the soldering iron, and then we're going to make some connections. So that's what we're doing next. Move that over there. These out of here. Now I do have to keep in mind my orientation of the BMS in these wires, because what I don't want to do is orient one of these in the wrong shape, or shape, listen to me, orient one of these the wrong way, and then not being able to connect it to the battery pack. So we're going to be a little mindful of which thing goes where, and that's okay. We got it. All right, so we got the station plugged in. Let me turn it on. And I get to turn on the heat to the iron, which is the right side. And while that's heating up, I'm gonna go put a little water on the sponge. Give me one moment while I do that. Okay, I now have a sponge. And we have returned to a cozy. Well, hello, hello. Welcome on in, cozy. Oh, the Snake Rider, hi. Looks like I have returned at just the right time to my own party. How we all doing this morning? I know for one of you it's tomorrow, and tomorrow is yesterday. Good to see you, the both of you, as always. Okay. So we're gonna get a little creative here and get an idea of how much wire I'm gonna take off of this. I shouldn't have left these over here. That's an awkward pull. Hooray! Indeed, indeed. I hope things are going well for a lot of you. Yeah, pop the insulation on this so we can do some soldering. So fancy. What is the Snake Rider and the Cozy up to this fine time zone? You're in mine now, so it's even better. Okay. So, for starters, we're not going to solder directly on plastic, so we are going to move some stuff around here. But what we need to remember is that we're soldering downrange, so we're going that way, and then that one will go that way. So the shorter one will be up here. That's the important thing to remember. Pinball! Ooh, that sounds like fun. Pinball sounds like a good time. Alright, cool. The iron is now toasty. And I've got the conglomeration of squid-like tool here so that we can do the thing. Say that as I hide my BMS underneath what I'm trying to do. It's fine. I'm not worried. I probably should be, but I'm not. Just got back from a little shopping. Happy to be in my own space again. Got slightly overstimmed. Yeah. Lots of stupid people in the malls who seem to not know how to walk in a straight line and keep to their personal space. That sounds about right. As a matter of fact, Snake, that reminds me. I witnessed today. You just reminded me. I witnessed today an individual that decided they were going to try to break as many laws as possible in the span of the same amount of time. Which sounds like, that doesn't sound like such a terribly smart idea. This individual ran a red light and then proceeded to turn the wrong way into a plaza. So I'm like, all right, we're speedrunning breaking the law. This is exciting. and I really like to make sure that I would give the benefit of the doubt in being like, oh, well, they're probably just lost and aren't really sure where they are. But they had their cell phone in their hand and they were clearly very much not paying attention. And I'm like, cool. I share the road with some fairly scary folks. Fantastic. Alright, so we're going to put this here so you guys can see what I'm doing. And then that with the negative side there. And then, yes, this part's going to be interesting. Alright, so we're going to attempt to do this in two parts. Because I think what we're going to do is we'll pre-tin the wire and then we'll attach it to the module. I think that's what we're going to do. We'll see how well it works. Yeah, it's amazing how many stupid people there are in the world. Well, so they're smart, and then there's just not really paying attention to the fact that other people exist. That does tend to come in an important aspect of life. When you do remember there are others around it. I'm convinced sometimes we forget. This is a hilariously large bundle of wire, so I may need to increase the heat on the soldering iron. We'll see here in a minute. Welcome back. Got to turn up the iron. We're not hot enough. Oh, you're right. Sometimes people do have a burn moments. But I think with my job, I see lots more people who are genuinely just not bright. You know what? Snake, knowing what you do, yeah, you're in a you're in a unique position, because you get to see the after effect. You get to see the after effect of a lot of different things, and yeah, no, that's I can understand your position without saying more. Am I going to ferality? That is a fantastic question. To which I'm going to answer with, right now, I might. I am doing some stuff that's going to overlap with that weekend, and I think that might land me in VR. It might not. But for certain, if I am, y'all will know where to find me. My timetable for the next couple of weeks is kind of all over the place. I'm about to have a very, very interesting month for the month of June. Yeah, no, absolutely. Well, by all means, Snake, you do know where to find me. So if you do find yourself at some spare time and you see me out around, you know very well you are welcome. Welcome all the time. I enjoyed the last time we spent some time together in VR. Always fun. Yee, exactly. Alright, I'm trying to do this and not burn myself at the same time. This thing is currently at 765 degrees Fahrenheit and it's not melting. That's exciting. And this is why we did the Grim connections first. I could go get out the flux paste. Maybe I should. I haven't tried using it yet. Something tells me this is probably going to be one of those times I'm probably going to need it. Well, it's not 700, it's 765. They're big numbers that we're playing with. I am melting a metal. Or at least trying to. Alright, we're going for the big ass numbers now. We're going all the way up to 795 in Fahrenheit. The solder's gonna melt, or the wire's gonna melt. Something is going to melt. This I can confirm. Oh god, no. If it was in Celsius, there's a good chance that I probably would have lost my hand. Even with the rubber grip. That'd be terrifying. I'm seeing a little bit of shininess. That's why I was concerned. That's fair. The trouble I'm having here, it's a little awkward. Let me move the iron around a little bit. I'm running into a position here where I'm trying to position this in a way that I can get good mechanical advantage. Because the other issue you'll run into with soldering is that if you don't have enough mechanical advantage, both down and up, you find yourself in a position where it won't make solid enough contact. That's part of the reason why I'm trying to pre-tin the wire, because I don't want to put all this heat on the module. I really don't want to fry it. I think I'm gonna have to get the flux out. And to be fair, Snake, it's just practice. That's all it is. 'Cause I'm still, you know, negotiable about how good I am at this. I can tell you right now, I need the practice. I don't want to try to do it with hot air because I really think that's just going to cause me more trouble. Not to mention that the lights will flicker if I turn on the hot air station, so I'd rather not do that. I'm not looking to pop a breaker. You cannot possibly tell me, you know, let me grab the flux. We are about to make a mess. Because flux makes a mess. Biggest lie on the packaging, the fact that it says no cleanup and it makes no mess. Ugh. Why did Fahrenheit 451 just pop into my head? Oh no. Alright chat, so here has read Lord of the Flies for school. My coworker didn't, and I'm wondering how baffled I am allowed to be. Well, I can confirm for you, Cozy, I am also in the same boat as your coworker. I also did not acquire the need to read what you have stated before us. I think I got Animal Farm too. I think I was in a similar boat. Oh, this is gonna be exciting. Oh, they didn't give me a pull tab. It's just a silver. Oh god, alright. Apparently you're not supposed to eat the stuff and keep it in room temperature. Good to know. Suitable for maintaining soldering, high SIR value, less residual, easy to tin, strong soldering, less smoke. So you claim. Shiny joints. Oh, you're rereading it? Interesting. Alright, I want to open it. So I'll open it with the Bear Grylls knife. Why not? Where did I put it? You know what? That's behind the iron. That's a bad idea. Let me grab it. Let me grab a different blade. Oh yeah. Oh, I am grateful I opened this up with something other than my hands. Well, that's interesting. There's some kind of like stop on the inside of this. I literally just opened this today. There's like a plastic retainer in there, almost like what you would find inside of a deodorant tin. Let's see if I can get the goofy thing out of there. This is the most bizarre. Guys, I'm gonna tell you something right now. This is one of those times that I wish that smell vision was a thing. Because I got it out, like I got it open, but I can tell you something right now. Like, are any of you familiar with the product known as Salmon Salve? It's like a vapor rub. It's a common thing that's used in the U.S. when people are sick, and to like open your sinuses in a less medical flavor. That's what this stuff smells like. It's really weird. Like it doesn't have that like it doesn't have like the Vicks smell to it, but it very much has the less burny smell. I've never opened one of these before, so That's educational. Alright. Now I've got my weird substance. I'm going to put it on the wire here and see if that can help out here. Let's see if we could work this up a bit here. Oh god, that was a lot. Okay. Oh god. How could this supposedly be mess-free? I'm gonna get covered in this stuff. Oh, Samen Salve. S-A-V-E-N. Salve. Not the adult product. Alright. I've dipped it in the substance. Let's see now. Let me move this out of the way. There you go. Thanks, chat. I know my language is a bit crap, but still. Alright, let's see what happens here. Oh, God. Oh, yeah, there ain't no way. My hand is getting awfully close. Readjust here. The rain's putting you to sleep, huh? Yeah, exactly. Smoke. I'll tell you something right now. It's definitely way more than low smoke than I would have thought. I won't be able to use any more of that in here tonight. I do not want to set off the smoke alarms. Alright, let me change my orientation here a little bit. Just a pretend these are really giving me a hard time. Alright, let's try that. I could try to do this, which I don't know if that's a good idea. If I try to do that, I probably should back the wire up a little bit. Sounds good, Porsche. Enjoy your sleep. I normally heat a joint from the bottom instead of from the top because I want the heat to transfer, but this is really thick wire, so I think I'm going to try heating from the top and let the solder move through the wire. At least that's the theory here. I see it as I'm really not getting anywhere here. Alright, well, let's bump up the spec here. Let's go up and away. New target's going to be 850 degrees Fahrenheit. Let's see what that does. Normally I have this set about 727 is about the ballpark I normally have it set to. But this is being a particularly stubborn time. Let's see if we just bump it up, if that'll get us where we need to go here. No, just kind of sliding around. I don't know what I'm missing here. I don't like it that the solder just keeps pushing out of the way. It's like it's just not hot enough. I don't get it. What the heck am I missing? You know what? I am reaching the end of this roll. Maybe the rest of this just isn't good solder. I have a new roll. Maybe I'll just open it and we'll just try that. I haven't soldered enough stuff to know when the solder is misbehaving, but I'm starting to think that that might be part of what's going on. I got a little ball off there. All right, that's what we're trying to do. All right, so we got one side nice and shiny. Now we're going to try to get the other side to also be nice and shiny. Boy, am I glad I'm using this really high temp silicon wire, because this little nub of wire is very, very hot. And the nice thing is that once it's pre-tinned, then the solder will just reactivate and it'll just flow. It'll just flow right across the wire onto the board. Alright, that looks like that'll be a decent connection. So if we can hopefully get through the others here, we can get it attached to the board. And then we can hopefully work on the next part here. Let's see, what time is it? Alright, well, we have a little time left. We can continue to play here. I kind of expressed to you how happy I was to hear that sound, and it wasn't the flux that fell over. As a matter of fact, I'm going to put the cat back on that right now. If this falls over, there's going to be a disaster in here. So we're gonna put that over there, or it can't fall over. All of you can see it, and more importantly, so can I. It's rocket science? Well, it's better than being brain surgery. Or brain science and rocket surgery. Idea of hands-on was using a Q-tip with isopropyl alcohol to clean a lens. Well, something I can tell you is that if you want to get into this kind of stuff, you just kind of just jump into it. That's the fun thing about electronics, is that there's no, I don't want to say no gatekeeping, that's not quite the word I'm looking for, but there's such an abundance of resources. So if you really want to get into play, you can. Alright, good. That looks pretty good. Nice and shiny all the way around. And then we'll do the same thing for the positive. I just need to like crank the heat. That's all I need to do to get this actually get us off the ground here. And it makes sense because this is really thick wire. So we just need to bump the base cannon here so that we can get the solder hot enough to melt. See, that's the trick though. That's why, if anything, if you want to play with soldering, you need to get yourself an iron that can go really, really hot. Because when you work with small components, with small legs that just pop through a board, like an LED or a resistor, you're working with a really small metal surface. And when you go up significantly in wire size, that wire turns into a heatsink. It's like that thing that keeps your processor cool in your computer. This wire is wicking the heat away. Well, the problem is that if I can't get the solder hot enough to overcome the wicking heat away effect of the wire, then it won't melt. Okay. So now that we've got all that sorted, now we can hopefully just attach and go. Now we'll work with the shorter lead first. And our goal here is just to use our already tinned iron, or tinned wire, to push the solder kind of onto the board. And then if we need to, we can add more if it's not enough. Alright, good news, bad news. Good news, it's started to adhere. Bad news, it's really close to this leg, so I gotta get it to boil and lift. It's too close. It moved forward on me a little bit. Hot. That's hot. I should know better. I didn't burn myself. I came close to burning myself, but I didn't burn myself. Alright, so the contact pad itself started to move a little bit. So I think we'll consider that good enough for right now. If I show you, there's a little bit of lifting on the side there where the wire made contact. But I think we're okay for the time being. We're just going to rock and roll here into the next one. switch up grip here. Trouble is the silicone wire gets a little slippery here when it gets hot. So it's kind of wiggling around like a little worm, trying to get the thing to tie in here. Ugh. Alright, slight change of idea here. Don't need to necessarily be suspended. Might be easier if I just put it on the base down here. Because this is perfectly heat resistant as it is. And there's a chance that it might take a little kinder to just direct pressure from down here. So let's try that. I have to love all those goofy little videos that you come across on the internet showing how unbelievably fast and simple this kind of work is. I can tell you that if you ever watch any of those videos, it's a lot of a couple things. It's perfected work, and it's also taking the time to really master the craft and speeding up the video. There's that too. Well, I suppose I could try putting down a small pool of solder first and just tack the pad and see if that'll help. The only trouble with using wire this thick is that it really doesn't want to play nice. Well, that doesn't even like attach at all, which is interesting. Now I've got two not connected solder balls sitting in the way, which may or may not be helpful. I'm not really sure quite just yet. Yeah, that's not really going to help. No, I take it back. They did get stuck. Okay. Well, now I've got an additional problem. Now they're kind of in the way. Well, the goal would be to get the entire thing hot enough that I could just kind of push the wire into it and get it molten enough. And that might potentially be what we do. Or, you know, they just kind of fall off like that. I mean, I suppose it's less in the way. So there's that. I'm convinced if I leave this on here long enough, it will boil. It's just necessarily know how long that's got to be. I commit, I'm a little worried I'm going to damage the component. Now, being a metal base that I have this sitting on right now, I'm hoping it's not wicking too much of the heat away, causing my problem. It's such a weird middle ground because I'm sure, yeah, I could feel the heat dissipating. All right, hang on, let me resuspend this. I really think that's part of the problem. It needs the open air to kind of just let bygones be bygones kind of thing. Because there's just too much heat sinking out from underneath it. So if we do this, hopefully this will be enough open air. Let it heat up. I don't know how much hotter I want to run the iron. That's the air trouble I'm having right now. Well, let me bump it all the way up to 900 Fahrenheit. I have no idea what this max out at. Oh, 896. Okay. We are going to maximum power. Well, we'll see what that does for us. I've never run the iron this high. I don't understand. That definitely should have stuck to the pad and just rolled off like it was water. No, I didn't even use flux on this one. Yeah, agreed. I don't know what the deal is here. It's so weird. They don't even want to incorporate. Let me open up my other solder and see if that's the problem. So this is 0.8 millimeter. What was this one? This one is 0.8. So they're the same diameter of metal. And they're supposedly both tin solder. Because the theory was to just have more of the same thing, because this was working up until a point. I'm fighting my shrink wrap. I have misplaced my sharp. Where the heck did I put my sharp? Oh, there it is. There's nothing worse than misplacing a sharp, because it's like an odd game of Where's Waldo. And if you don't find Waldo, he's going to stab you. So, yeah. We have to be a little mindful of that. Alright, this is more rosin core solder. I got it open. So again, it's very similar to what we were just working with on the other roll, except this is a new one. And we'll see if this gives us any kind of different results. I want to see if I just try to tack the pad with some of this, if that'll stick. Or just roll off. Let's see what happens here. I already tell that's different. Alright, well, good news, it seems to at least be behaving a little bit better. I think what happened is I just got a little too much of the rug and core on the pad. Oh, interesting. Okay, hold up. I might be attacking this wrong. That melted instantly when I tacked it from the front. Alright, let's try that again. Let's tack from the front. It's like working with a piece of wet noodle. This silicone-based stuff is wild. Stay. We got that there. Hit you from the front. No. Are you camera shy? That's really what I'm starting to wonder. I think I have camera shy wire. I promise the folks at home aren't going to judge you if you could stick to the board. That'd be fantastic. Seriously. That's wild. I hold it in the air and it melts. As soon as I attach it to the pad, it goes, who this? I don't understand. I genuinely don't get it. What am I missing? This wire is so ungodly hot. Man. Air issue is I'm going to damage this thing if there's too much heat that goes into it. So let me give it a break here. There's actually not too much heat on the other side of this, which is good at least. Seems that this other solder does melt faster. I'm gonna try to tack it from the ground again here and see if it'll do anything. I really don't think I need to add any more. It seems to be pretty well impregnated with solder at this point. It should just stick. Just a case of when in Rome, right? I think it finally joined. As much as I don't want to, I'm gonna have to add a little more solder to the negative lead, but we do actually have contact. It's just there's a lot more pad visible on the negative lead. So as much as I really don't want to touch it, I'm going to. Since this is the fundamental basis of the battery pack, I need this to be a solid connection. I do not want to think about the fact that I have more. I do, in fact, have to solder to this goofy thing. Well, I guess we'll see how we do. For the time being, the pad looks like it's still partially lifted, but it looks like the joint looks a lot better. All right, cool. So that means we got one more we got to do. We got to do the BM side, and I'm liking this just kind of pushing on here and adding more as we go. So we're gonna do the same thing for this one, since that seems to finally actually be doing stuff. Yes, exactly. Still a victory, and we're gonna take it because I find this to be a bit of an odd challenge that we got before us here. All right. Well, attached. Seems like it's a decent connection. That's our BMS line. So then the next order of business is a bit of a sketchy one. And that's going to be the connection to the regulator and the connectors that are going to go off the battery contact.
I think it would probably be worth me double checking to make sure that I didn't damage this component with the amount of heat I dumped into it. But for the time being, I think that's probably where we're going to end it for the night. And then we'll do a little revisit action and continue on with the story. For right now, I'm going to toggle back the temp here on the soldering iron. Ugh.
All right, solid. So that's where we're going to leave it for tonight. I'm happy we're making progress. Unfortunately, it's very, very slow progress, but it's the beginning of taking out some stuff that I have not done before. This is easily the thickest stuff I've ever tried to solder. And obviously, as we can tell, there's a bit of a learning curve into that. Swapping out the solder did help a bunch. So I think the rest of that little bit of the green roll is just not as well impregnated with rosin. Rosin core solder is a tin-based solder with a rosin like gooey center is the only way I could really refer to it as, which helps the metal melt and flow through what you're soldering it into. And if the mix isn't quite right, as you can see, it just doesn't want to melt. Once it does hit the point, and it just plops into the wire. But as you can see, that does definitely cause some significant trouble if it doesn't melt quite when you need it to. So with that, let me take a quick look at the calendar. Let's see here. So we will return for next Wednesday to have some more fun and shenanigans. And then if any update to where I stand with this occurs off camera, there'll be some pictures in the Discord. If not, we'll just pick up where we left off.